My name is Naikudi Shubham Shivaji from ENTC department, last year student. My college name is Jai Hind College of Engineering, Pune. My internship project, IoT-based home automation solution. Next one is the next slide.
So first of all, introduction. Let's we talk about what is IoT. So basically, IoT is connects the device with internet. It collect the data and share it. It's basically collect the data from the sensors and it gives this data to the cloud and we can see the data on the dashboard. It is basically used in smart systems and IoT stands for Internet of Things. In our day-to-day life, we have to use IoT so that we can monitor our uh, daily life things. Now let's talk about problem statement. So we are working on smart factory IoT monitoring system. So we know traditionally factories rely on manual monitoring. We have to go to each part and check is there any fault or anything. All these things are done manually. So there is no smart monitoring system and there is no real-time tracking of environmental conditions. We don't know what is the temperature before 10 seconds, before 10 minutes, before a hour. So we have to develop something where we can track real time. So next problem is there is delay in detecting critical issues such as temperature, humidity, etc. Because of this there is very less production and there will be delays in the delivery of the products. So detecting the critical issues is most important thing in the factory management. So with this smart factory monitoring system are unable we are able to track a real time data of environment and because of this we can overcome the critical issues. And in a in traditional systems there is lack of automation in controlling system. Because of this there is no proper automation. We cannot automate the systems. We have to do each and everything manually, and there is no centralized dashboard for monitoring and control. And hence because of this we have to rely on different systems for different tasks. And because of this in our smart factory management system we have developed a specialized central dashboard where we can monitor each and every aspect of project which required in a single way. Let's talk about objectives. The main objective of our smart factory IoT monitoring system is first of all we have to design a smart factory IoT monitoring system where we collect the data from the sensors and it give to the cloud where we can represent this data on the dashboard. And with the help of some controls we can manipulate this data easily. Next objective is to enable a real-time monitoring of temperature, humidity, and other parameters. Other parameters are such as motion sensor, is there motion is done, is dark, and etc. And we have to implement automation based on sensors data. Example, ventilation control. So if the humidity is greater than certain limit, we will start the ventilation. We can manually start the ventilation as well as the automatically. So this is another objective of our project. Another objective of our project is to provide a remote monitoring and control using clouds. Because of this we can monitor or control our factories from another place where we from another place out of the town, etc. To another objective is to develop a dashboard for visualization and alerts. This is one of the most main objective of our smart factory IoT monitoring system. We have to develop a dashboard for visualization and alerts. And because of these alerts, we will get a data significantly. The another main objective of our system is getting the data of real-time monitoring. Next, we will talk about system overview. So basically in this IoT project, we have constructed a two nodes. Node 1, which is a production line monitoring, and node 2, which is a warehouse monitoring. In production line monitoring, we monitor the production line where we monitor the temperature, humidity, motion, light, and temperature of the machines, etc. Here we use the Arduino for processing the data and PiximLab for the uh, simulation. Next is data is sent to Thingsboard cloud using MQTT protocol. Here we use MQTT protocol for data handling on Thingsboard cloud. Dashboard displays real-time data and alerts. The dashboard is displays all the real-time data and alerts. And this system supports automatic and remote control RPC. Next, we will talk about software and tools. We will discuss about software and tools use. We have used Arduino IDE for writing the code and compiling and uploading the code. Next, we have used PiximLab, which is used to simulate Arduino and sensors. It is a virtual environment, so there is no need of hardware. Then we have used Thingsboard Cloud. We use the Thingsboard Cloud for data visualization, dashboard, and device management. Then we have used MQTT protocol. We use MQTT protocol for communication between devices and cloud. Now let's talk about system architecture. We know the system follows a three-layer architecture. First layer is perception layer, second layer is network layer, third layer is application layer. Let's discuss about perception layer. Perception layer is also known as sensors and nodes layer. In this layer, we collect the data from the sensor. Basically, in this layer, we have to collect the data from the from the sensors such as DHT22 sensor, LM35 sensor. From DHT22 sensor, we collect the data of temperature and humidity, whereas from LDR sensor, we collect the data about light. From LM35 temperature sensor, we collect the data about temperature. Next layer is network layer. This layer is also known as MQTT communication layer. In this layer, we transfer the data from nodes to cloud using MQTT protocol. Here, basically, we transfer the data collected from the sensors to the cloud. Basically, this layer is collection of data and sharing of data. The next layer is application layer. This layer is also known as Thingsboard cloud layer. Here, we display our data on the dashboards or clouds. So, here we store the data and display this on dashboard and manage alerts and control. So data flow is we collect the data from sensors, then this data is given to the Arduino Uno. Then with the help of MQTT protocol, this data is given on cloud, and on cloud with the help of dashboard, we control and monitor the data. So let's talk about further things. Here we can see clearly what is application layer, network layer, and perception layer. Now, Node 1. Node 1 is production line. In Node 1, we monitors production line conditions such as we read the temperature and humidity. Here for reading the temperature and humidity, we use the DHT22 sensor. Next, we read the machine temperature. For that, we use LM35, and we also read vibration. Here we use ADC sensor, which is potentiometer, as there is no vibration sensor is available in PiximLab. Next, we detect machine status where machine is on or off. If machine is on, then LED will be green. If it's off, then LED will be red. Now we also control the relay and LEDs to RPC control. Now we send this telemetry data to ThingsBoard cloud and we control relay and LEDs to RPC. This provide us real-time monitoring and alerts. Here we can see clearly on dashboard temperatures, temperature, humidity, and this is time series chart where we have plotted the temperature and vibration according to time. This indicates machine status. This indicates sensor error. If there any error in this sensor or is there any loose connection, then here we will indicate the sensor error. And this is another time series table where we use all parameters, weather, temperature, humidity, LM35 temperature, machine status, relay status, sensor error, and vibration. All this we have learned in production line. Next, talk about warehouse line. This is a node 2, which is warehouse. Here we monitors warehouse environment and security. Here we reads temperature. Here we reads light level, where light is low or high, and hence we can detect is dark or not. When then we have used motion detection, PIR sensor. Then we use door status. For door status, we have used switch as there is no proper sensor in Pixim lab. And because of this, we detects dark environment using is dark, motion, and door is opening. And here we also have implemented automatic ventilation. If humidity is greater than equals to 85, then relay will be on, and because of this, ventilation will be start. And this all data is sent to the ThingsBoard cloud, and which supports remote control to RPC. So here on dashboard, we can clearly see temperature, humidity, LDR value, and this is ventilation override. Here, if humidity is greater than 85, then this will on. Now door status is door is on or off, is dark. What is the if there is proper light at after certain if there is proper light it will shows on, otherwise it will be off. Motion detection, is there any motion, then it will be green, otherwise it will be off. And here another is sensor error. If there is any error in the sensor, it will be light up. And this is time series chart. Here we plotted humidity. So let's now talk about results and skill acquired by me in this project. So let's talk about results. I am successfully implemented smart factory IoT monitoring system. Real-time data monitoring is achieved by me. Then automatic ventilation based on humidity is also achieved. Here the ThingsBoard dashboard displays the live data and alerts, and we have implemented remote control using RPC. All these are the results which we have implemented during the project handling. Now the skills I acquired are the knowledge of IoT systems and architecture. I get hands-on experience with Arduino programming. Uh, Basically, I understand all MQTT protocols. There is experience with ThingsBoard dashboard simulation using PiximLab, and my problem solving skills and debugging skills are improved a very lot. All these are the skills acquired by me during this project implementation. Next, future scope. So basically we can implement this system using real hardwares in industry, not only making this on a project scale. We can implement this using real hardwares in industry so that it can be very useful. Now we can develop a mobile application for remote monitoring and control. The mobile application make the data handling very easy. We can add AI ML based prediction for fault detection and maintenance. Because of this, the fault can be detected before the time, and we can predict the future, whether there will be any need of maintenance in future using the AI/ML models. We can improve system with advanced sensors. We can improve the system with advanced sensors which are available in the market, and we can increase the number of nodes, because if we increase the number of nodes, the monitoring of the system will becomes more and more easy. We can enhance security features or add the security features such as authentication, encrypted communication, etc. So let's talk about conclusion. We have designed and implemented a smart factory IoT monitoring system. We have achieved a real-time monitoring of production and warehouse nodes. Implemented automation. Here we have implemented humidity-based ventilation automation. We enables remote monitoring and control using cloud system. Because of this, system becomes reliable, scalable, and efficient. Thank you. So let's talk about project demo. So this is node 1. Here in node 1 we have created all these files. Now let's talk about node 2. In node 2 we have created all these files: sensor manager.cpp, sensor manager.h, telemetry.cpp, telemetry.hh. So basically this is a node 1 which is production line. This is LM35. This is DHT22 sensor where we have temperature and humidity. Here we have temperature. Now this is vibration sensor. For vibration sensor we have used a potentiometer. For machine control we have used a button. This is for relay status. And now this is our three LEDs. If the system is proper, then green light will be on. If there is any error in connection, like connection is wrong, then this yellow LED will be blink. And if there is most this error, then this light will be glow up. Now let's talk about warehouse. In warehouse, we have DHT22 sensor. Here we measuring temperature and humidity. This is PIR sensor. For PIR sensor, we have used the switches. Because of this, we can detect any motion is there or not. We have used LDR sensor for light. This is door is on or off. This is ventilation relay. If the humidity is greater than certain limit, this ventilation relay will be green, and all this stuff. Now let's talk about things. Let's talk about things about cloud. Let's check our all three dashboards. So this is production line monitor. This is production line. Basically, this is production line monitor node 1. Here we can see clearly temperature level is 36, humidity is 48. So let's check in production line. If I'm right, yes, production line. Let's check in for production line. This is production line. Now we change the temperature of LM35, all this, and now check. Sorry, I have done mistake. Okay, let's check. Here we have seen that there is change in temperature. Now machine status is on, relay status is on, and sensor error, there is no sensor error. And here is we getting the data printed. Here we have used alarms. This is high temperature alarm. Severity is critical. If the temperature is some line above, then it will show critical. Now let's talk about second dashboard, which is warehouse monitoring. Warehouse monitor, which is node 2. So let's change the temperature, humidity, all that stuff. LDR, okay. So here temperature is minus 25, 65. LDR value is 2. देखो okay, now this has been changed as temperature is very high 40 degree, humidity is in between that this is fluctuating as I changed the values. So this is door status, this is dark or not, this is motion detected, this is sensor error, and here we have seen the time series charge of humidity. Humidity is fluctuating with time. This is time series table, and these are the alarms which we have created. Now let's check is there a will be ventilation is working or not properly. So if humidity is greater than 85 or 90, relay should be on. So this is working properly. So here, so let's change humidity. So we can see here as I change the humidity, there is dip in the humidity. Here humidity is 64. Now we have changed its value. We have changed LDR value. We have changed temperature value. Now we can check it. So all this is our node 2. We can see all these changes as I change my humidity value. It has been changed. As I change my temperature value, it has been changed, and LDR value is also changed. Now we talk about smart factory. This is the combination of both the warehouse and production line monitors. This is warehouse node 1 data. This is node 2 data, and this is time series charge for it chart for it. Okay, all these, and these are the two devices, warehouse and production line. Thank you, thank you everyone.